Okay, so I am starting now. Welcome to the International Commission on Irrigation and Drainage, the webinar series, and in the webinar today, next slide please. We have the role of ICT technologies for sustainable irrigation management and scheduling, MENA region case studies. This is a very important seminar today because the value of water is realized only after measuring it and only after assessing it. And for measuring and for communicating the information pertaining to the water, the ICT technologies are playing a very huge important part. And with the rapid advances in the ICT technologies, a huge number of opportunities have come up in which we can bring in various stakeholders together and provide them with the real-time information to optimize the decisions and to optimize their outputs. So this seminar is something which is of a very great importance to all of us, and we are very happy to have with us two very eminent faculty, Dr. Amgad Elmahdi, the Director of MENA Region-IWMI at Cairo, and we also have Professor Dr. YILDIRIM. He is the Dean Faculty of Agriculture at Eskisehir, Osmangazi University, Turkey, and Chairman of the Irrigation Association of Turkey. So we have two very learned persons with us. We will be starting with Dr. Amgad first, and then we'll go to Dr. Yusuf. So let me first introduce the our first faculty, Dr. Amgad Elmahdi. He is the Water Systems and Solutions Specialist with over 25 years experience and also expertise in hydrology, water resources, water assessment, water accounting, water governance, water information management, digital technologies for water management, water policy and planning, nexus assessment and management in operational research, etc. Dr. Almadi has served as water system analyst and water resources manager before joining IWMI. He was the head of water resources section and chief supervising hydrologist at Bureau of Meteorology, Australia. His experiences involved providing evidence-based science and low-cost solutions to sustainably manage water and land resources for water and food security, people's livelihoods and environment. He is also a recognized international water and natural resources management expert and Australian representative for several international agencies such as ICID, and he is also chair of Water Security Bureau, the International Water Resources Association, IWRA. He has received several awards nationally and internationally for his science impact for landscape water modeling in Australia and Strategic Excellence Award for Partnership and Water Saving Award of ICID. He will be speaking on role of ICT technologies for sustainable irrigation management and scheduling for the MENA region case studies. So now I will invite Dr. Amgad Elmahdi to make his presentation, please.
Sir, can we introduce the other presenter also so that there won't be any disturbance?
Okay, then we will also go ahead with the introduction of our other learned speaker, Professor Yusuf Ersoy YILDIRIM. He is the Dean, Faculty of Agriculture at Eskisehir, Osmangazi University, Turkey, and Chairman of Irrigation Association, Turkey. He has graduated from Ankara University, Faculty of Agriculture in 1986, and he completed his master's and doctor's education at the same university. He has attended irrigation trainings in Italy and Japan. And between 96 and 99, he worked as a postdoctoral researcher at Cornell University and University of Nebraska, Lincoln in the United States. He became professor in 2004, and he is currently a faculty member of Ankara University, Faculty of Agriculture, Department of Agricultural Sciences and Irrigation, and he is also serving as the Dean of Faculty of Agriculture at the university. He is also chairman of the Irrigation Association of Turkey. So we have two very learned speakers, and we will be starting with Dr. Amgad for his presentation on the topic that we just now said, the role of ICT technologies, and we look forward to hearing his remarks. So I will invite Dr. Amgad for his presentation.
Thank you, Pandai, and I hope you hear me well. Dr. Amgad, just wait, because just information for the attendees that they can share their questions through questions, and then we'll pass on their question to the particular speaker, and then in the end, these questions will be replied after the presentation. Both the presentations are over, and we may give some speaking right to some of the attendees also. For that, they can raise their hand, and then we can, as per the time, we can provide them speaking right, and they can directly interact with the speakers also. So now, Dr. Amgad, you can go ahead and give your presentation. Thank you.
Thank you, and I hope everyone see my screen and hear me well. Yeah. So,
Dr. Amgad, we are able to see your screen.
Okay, perfect. So today I wanted to talk to you about the role of ICT technologies for sustainable irrigation management and scheduling in the MENA region. So before I start, just to give you an idea on what is IMI, or Water Management Institute, quickly. So it's an international institute with a headquarters in Colombo and 15 offices around the world. We have released our new strategy in late 2019 that actually looking at 3 key programs: water and food and ecosystem, where we're looking at how to improve the food security, how to conserve the ecosystem and water resources. The second program looking at water, climate change and resilience, and that's where we're looking at how to adapt and mitigate really the climate change impact and how to build that level of resilience within the society and community. And the third, it's really the water growth and inclusion, and this is where we're looking at the sustainable growth and gender equality and inclusive society. That's supported by a number of cross activity like digital innovation, where the focus today will be on the ICT as one of those type of solution that digital innovation provide, and also the circular economy and governance and equality as well. In the MENA region here, we have our main office in Cairo as a regional office, and we also have sub offices in Beirut in Lebanon and Amman in Jordan. So let's start with looking at the MENA region and what are really the key challenges we are facing in the region here. So in the figure in front of you here, what you see is, for example, if we look at Egypt, we will see like the top 3 priorities are really climate change, the food system vulnerability, and population growth. And that highlights really the need to work in the country. But if we look, for example, in Morocco side, far west, you will see really the key challenge or the key priority is really the food system vulnerability. If we look at the Gulf countries, you will see number 1 priority is really the energy price volatility. And that actually what we learn from that, it's really we have a common challenge, we have a common issues, but when you try to address them, you really need to address them locally. And if we look at this, what does it mean, those challenge, and what is actually their impact? So if we look at water scarcity, so MENA region, it's one of the hot scarce region, and we have seen 60% of our population living in water scarcity, but also we know by 2050, we really need to increase our supply by almost 55 to 60%. And the reason for that, we have a high rate of population growth and high rate also of urbanization. So we know by 2050, 75% from our population will be living in urban area. We know we are facing climate change with like increasing temperature between 2 to 4 degrees that being reported, and that actually increase the frequency or the chance of facing drought by 60%. We're also living in a region where conflict and migration is really a key challenge, and that adding on the fragility of the region as well. But we also see the change in the lifestyle and diets as well. And we're living in a region that rely on 50% of their food to be imported from outside. And of course, energy, again, as a source to abstract water and for food production, again, it's another challenge. we're living in a region that actually producing energy, but still we are not able to meet our demand. And of course, with all of that, environmental degradation as well, with really impacting our GDP by 20% to 6%. So to summarize that, if we look at the SDGs, we really having less than 10 years to harvest. And we have seen like a systematic crisis problem that really requires systematic solution or systematic approach to be able to solve that. And then we been hit by like COVID-19 in 2019, that's reflecting a recession that come again with the big elephant in the room like climate change, but again, biodiversity collapse as well. So when we took the analysis and level of understanding, we know about the region to the first Ministerial Council for Water and Agriculture under League of Arab States, and we give them a summary of like a new generation of policies and investment. That really highlighted really the need of using ICT as one of the key investment area and also as one of the solution under climate smart agriculture solutions. So to translate that into an activity and action, so we really first need to understand the capacity in the country and the need assessment. So we did that in Lebanon to try to understand really the capacity of the country in terms of the public, the NGO, non-government organization, the research, and also the private sector. And what we found actually, there are many initiatives already there. And the capacity in terms of like using GIS, remote sensing, and access those data, it's already there as well. Donors are also interested to support that type of work, like climate smart agriculture or ICT solution. And there is already a number of cooperation between research and public organization, including even the private sector coming as incubator or acceleration for those startup where they bring the technology. However, on the other side, we know there is also an issue with public administration really to buy into that new solutions and that new technology. And that could be, again, by lacking of some experience. But also we know that extension services are really dying in most of the countries. And the reason for that, it's adding more pressure on the budget of the country, but also there is no new recruitment as well. So there is no job creation. And that reflected in like poor communication as well, and getting that information that really farmers need on their farm to make a daily decisions. And of course, we know also the cost of the technology sometimes also become high, and that adding more challenge as well in terms of using that technologies. But when we look at the farmers and in terms of like the existing use, are they actually using any ICT solution? Is there any needs, and what is their perception about that? And also, can they access the information, and how they access this information? But also look at like how the water system being governed as well, and the different type of water source they have used, and also the type of crops they use, and the farm side, the level of education, just to understand what is happening. So I will not share all the results, but it's just like a snapshot of really some of the results. So in terms of like age and education of our farmers in the region here, so we found around 65% of the farmers are really more than 50 years in terms of age. And that, of course, adding a challenge in terms of the new generation of farmers. But also, if we look at the farmer size and education, you always see like the educated farmer always work in a large farm. And with the small farmers, you always see the level of education is quite low. But in terms of access to internet and technology and using a smartphone, so on average, we have almost 65% having access to smartphone and internet as well. And that, of course, make that type of landscape is ready to support those type of new solutions or platform. But also when we look at like how farmers actually using the information, are they actually rely on using that scientific information or just rely on traditional knowledge? So normally with all farmers that having like a small land or less than 500 dunam, like 50 hectare, that actually come as like, yeah, they really rely on traditional knowledge because they don't really have access to the scientific knowledge in terms of like crop water requirements or when they need to irrigate, how much they need to irrigate. But with the large farmers, as they are investing in a big farm, they are willing also to invest and look at how they actually using that scientific calculation or the scientific information. In terms of the decision making on the farm, so most of the farm really rely on the field and weather observation that actually receiving from just news, but they actually looking for more information in terms of how it can help them in terms of when and how and much water to irrigate. And they are using what is just available to them. So taking that level of understanding, we start looking at this project where we aim to like improve the productivity through the role of ICT. And I will share with you the two examples we did for Lebanon and Egypt, and also reflect on some of the lessons learned because we have applied different models in a way we work and develop those ICT solutions in these two countries. And we have like the main goal, and the main goal was really to start to working on the irrigation aspect, but we have the aim to digitize the agriculture extension service. So if we put a specific objective for us was really to develop that mobile application that supports the daily decision on farm related to water management. And that should help really not just the farmer, but also the extension service or any other person that's really interested in agriculture sector. So we selected the two countries like Egypt. So we look at the Delta area where has like a very small land ownership and also very old tradition system with most of the region are really flood or furrow irrigation. In Lebanon, we look at Bekaa Valley, which again, it's old and more tradition agriculture and more vegetables, but also they using a lot of drip irrigation as well, as they are really growing like grapes or table grapes. So we put the plan for us, and the plan really involves 7 steps. So first, we need really to select and decide on the main crop we are going to tackle for each country, because we are not going to start by doing for all crops. And we also need to look at the remote sensing data, in particular like Weber data set that being developed by FAO and work at 3 level, that 250 meter for global scale, 100 meter for national scale, and 30 meter for local scale. But we also have the opportunity to look at other remote sensing data that's already available as well for the region for crop water requirements. And we have to evaluate the potential use of that also for the crop health. So how we can actually use that information to inform the farmer about how their crop actually behaving during the irrigation season or the agriculture season. And we also try through the process is really to get the local information or local validation as well. And also we need to review all that information with the local partner to ensure that information are valid. But in terms of the design of that application, we aim for actually a co-design application where we try to capture the farmer's need and inputs in terms of the design as well, including, of course, gender aspect. And then we looking for like how we can assist that app and do a test trial in the farm and also on the ground, and that to build really the confidence in using that application by the farmers as well. And of course, the final design need to be launched and released, and also provide training for a trainer like the extension service who actually talking to the farm on a daily basis, but also provide training as well to the farmer. And we have set a different type of KPI for us for the two countries. So for Egypt, we were aiming to tackle the summer crops like 5 crops, work on 3 govern rates within the Delta area like East, West, and the middle in the Delta. Train 5 extension service, but train also around 90 farmers, and we're aiming for 150 user for that pilot. But also we're aiming for improving the accuracy and get the design to be more user-centric design, and also the user need. In Lebanon, we aimed only for 3 crops and only 2 govern rates, and more or less the same other items. So how did we go with that? So in Egypt, we engage with the local public institution like SWERI, like Soil, Water, Environment Research Institute, which is under the Ministry of Agriculture and Agricultural Research Center. We also joined the universities as well, like University for Modern Science and Art, where they actually supporting or incubating the startup as well. And of course, FCO was our partner. In Lebanon, what we found, there was already an application there that managed by LARI Institute, or Lebanese Agriculture Research Institute, as a public institution under Ministry of Agriculture. And that application used to provide weather information and also used to communicate with the farmers as well. And we also have FEO as a partner there. So the big difference between the two was, in Lebanon, we have already an existing application where we try to upgrade to bring in that irrigation aspect into it. In Egypt, we started from scratch because at that time, there was no other application that actually provide that. And we also engage the startup. So in terms of using AT products or remote sensing products, so we went through different type of products by looking at those products, looking at the level of data extraction, data availability, how easy we are able to assess and process those data to be inform the app or become as an input into the app, and also the different type of outputs we are able to produce and validate as well. And the decision actually came to use the Weber data, as it's much close to the local condition, and that was accepted by our local partners in the two countries. So how we establish this? So in Lebanon, as I mentioned before, so we have used the existing LARI application. It used to be called LARI Lib app. So we got in partnership as an international organization with a public institution. We try to work with the end user because they already have a user, around 600 user already using the app, and that was a plus from the start. So you're upgrading an app that already has a user as well, and we try to capture their inputs as well. And we decided to tackle 4 crops at that stage, which is the table grapes, the potatoes, the wheat, and soybean. In Egypt, it was different. As I mentioned, we started from scratch, there is no an app. So we get in partnership with a public institution like SWERI, under the Agricultural Research Center. We also bring with us the startup companies, so young engineers with fresh mind and with the know-how as well about the technology. And of course, we have the opportunity to bring the end user from scratch. So to discuss the early design and also which crop we really need to tackle and focus on. We agreed to work on like 7 crops, rice, cotton, soybean, maize, potatoes, beetroot, and wheat. And that was really the focus for the Egyptian application that we call it IRWI, IRWI. So the inputs for the two models are not really different to some extent. So they are looking at the farm location. So they define the farm location, they define the area that being planted or cultivated, the type of soil, is it silt or clay, the crop type, of course, you can select between the different crops we have focused on in that work, and also the irrigation method, is it furrow irrigation or spray or sprinkler irrigation. But also you define about the water pump, the type of pump you are using as well, and the source of water, is it a surface water or a ground water, the planting date, when did you start to plant, the soil salinity, so you look at the flushing factor as well, and the last irrigation date, so any farmer can join the app at any time, and then the application start to work based on the last irrigation date, because for example, the farmers in Egypt, they work on a rotation, and their rotation could be between 10 days to 14 days, so they don't have really access to water every day. But also the full price, and also the type, is it diesel or benzene or petrol. And the outputs from those two apps, it's really to tell the farmers at any time they access the app based on the last day of irrigation, based on the crop type, based on the irrigation system they have, the soil type they have, the water requirements, and also the weather information as well, and also the energy requirement and the cost for their irrigation, the estimated irrigation record, and the actual irrigation record. So they become as a notebook for each farmer as well, and the harvest crop and the expected yield, and of course the crop health as well. So the farmers can actually get that information, and we actually transfer that information, not to tell them really how many cubic meter or liter, or we actually tell them based on that information and that input for how long actually they need to operate their pump. So we transfer the information for the way they can really understand and the way they interact with the information, which is turn your pump for 1 hour and 50 minutes for your field, based on your crop, based on your type of pump. And of course, we have to do a training. So we have trained the extension service as one-to-one training, but also we have trained the farmers as well. So we went to the farmers in a group like Water User Association, or in a village where we sit with the farmer and we tell them the application, how they can identify their farm and how they put the inputs, and then how they can use the information from the farm. But we also went on a ground trial. So we went with some farmers on their field on the day of irrigation, and they use the app, they find the information, how much water they need to irrigate, or how long actually they need to operate their pump for, and they start to apply it on the farm. And that actually build the confidence in the way they used the application. Of course, we collecting feedbacks, and the feedback was really interesting. So the farmers actually looking for more. So they were really asking for, like, can you give me the market price? They are interested to know the market price. They are interested to see like the feasibility study for the crop, so they can decide on which crop they actually to grow in their field. They want to see some profitability analysis for different crops, so they can take an informed decision as well. They asking, of course, for more crops. So they want more crops to be included in the app, and not just the crop, but also even by varieties as well, because they have the feeling based on the variety, of course, the irrigation or the crop water requirement will be different. They wanted to be informed about also heat waves and frost as well, as a major impact on their farm. The pest control or the pest outbreak, they wanted to be informed about that as well, the diseases of the plant as well. And they even asking for, like, can you give me a life assistance for the crop health? So they were able to describe exactly the service they want. Can I just take a picture from my field and send it on my mobile, and you tell me what that disease is and what is the treatment are? And of course, the key thing for them was really the crop price in the market, so they know how they can actually generate more profits. So as a lesson learned from those two trials, the one in Lebanon and the one in Egypt, and the two applications now are available on Google Play and also Apple Store as well. And every day there is a new user coming on board. So for Lebanon, we found the advantage really by working directly with a public institution with an existing application to upgrade. We found that actually give assurance of the information, because it was already there. It's coming from a public institution, so that hasn't taken long from the farmer to accept the information that the application produce in terms of irrigation. But it also gives us that level of sustainability as well beyond the project, because there is already owner for the app, which is the public institute, and they were happy to, of course, to carry that forward beyond the project. And of course, the uptake as well. So you started with already a list of users. There is already user there. So it was easy to make like mouse-to-mouse word to increase that usership as well. But of course, advantage also come with disadvantage sometime. So in terms of the disadvantage, because we are working with an existing application who is already built in a special platform, that actually limited us in terms of how we can design the irrigation module, how we make the farmers interact with that irrigation module, because you work with that existing technology that already become to some extent an old, like 5 years ago. So that limited that. And again, it didn't meet all user needs, because with that limited flexibility, again, that was doesn't really meet every user need point. And of course, the time frame, it takes longer, because again, you work direct with public institute, the development actually being done by the public institution as well. So it takes time, or it took time actually to be developed and released as a new irrigation module. However, in terms of Egypt case, where we get in partnership with public institution, with also startup or private sector, and bring in the end user from the beginning, and we have a white blank page to start with. So we've been able to choose the right technology that give us that level of flexibility, because we know that what the country planned for the digitization for the extension service. So we know we're starting small, but we know the end of the goal, or our end goal, and we take that into consideration. So being able to choose the right technology to be more flexible, so we can continue add in new modules. We've been able to capture the user need from the beginning. And by joining or partner with the public institution from the beginning as well, and using them to validate as well all the information, that actually also make it that assurance level of the information for end user as well. In terms of sustainability, yes, we managed to do the ownership agreement and transfer that technology to the public institute, and that give again that level of sustainability, because from day one they were engaged. So they have the level of or the feeling of ownership as well, including even farmers. So in many cases, we found actually farmers stand and explain the app for their farmers during the training, like their neighbor farmers. And of course, the uptake, because you manage to meet their needs, you give them the assurance of the information, so they really help in the uptake as well. In terms of the disadvantage, what we found is really, you really need to do a good campaign to bring that application to the knowledge of the farmers, because it wasn't there. There is no user already there. So you have to consider that campaign in the development, and you work on that campaign along the time before you launch, and of course after you launch as well. And of course the ownership take a lot of discussion as well, because you have to reach that agreement of ownership. So again, you need to plan time for that type of discussion of ownership. So to summarize, like a take-home message really from that experience in Lebanon and Egypt in the MENA region, really the government and public institution, including NGOs and private sector, are really taking those initiatives very positively as well. However, you really need to consider and understanding the diversity of the different water source, the different water user, the incentive for those farmers as well. So you need to consider the incentive for every partner, like why they will come and join you as well. But of course, there is a clear need from farmers, and also readiness, a good level of readiness from farmers to really adapt to that technology and adapt to the information that coming from that technology. ICT tools in water management are really in need. We cannot ignore the fourth industry revolution, and how the technology now become simple and cost effective and available. So it's a matter of how you can customize that technology to be able to use in that different type of applications, for example, in like irrigation or extension service or disease identification, and also the treatment. And that will make it very easy to be adapted. Partnership, again, it's quite important. You need to consider the right partnership from day one, like in terms of public-private, where the private actually bring the know-how, bring that new thinking and new technology on board. Centric user design, it's really quite essential for any new ICT solution, because you really need to make an application that meets your user needs, and user need including gender aspect as well. And of course, ownership. Ownership actually assures sustainability. So when any development or any project finished, someone need actually to maintain that and have that level of ownership and sustain that information. And in terms of our success factor, really, we have went beyond our KPI, and that was really a plus for those two applications. And again, it's assure like how the region is really ready to accept the ICT solution and actually to use the information that's coming, and they are actually looking for more solution under ICT umbrella and more information to come. Thank you, and I'm happy to take your question. And I'm sure also you will hear from my colleague from Turkey as well about the different solutions as well that being done. Thank you, everyone.
Thank you, Dr. Amgad. It was a very interesting presentation, looking at the field level experiences of implementing the ICT solutions. And we will be taking the questions after all the presentations. And in the meanwhile, any questions are there, they can be typed in the chat box, and we'll try to pass it on. We have the next presentation from Professor YILDIRIM from Turkey on information and communications technology applications in irrigation projects in Turkey. So now I will invite Professor YILDIRIM to make his presentation, please.
My presentation, can you see it?
Yes, we can see it, yeah.
Okay, just a second. Hello, everybody. Good afternoon to everyone. I'm actually irrigation specialist, also in academic side at the university. Also, I am working on some cooperative irrigation associations and also some governmental agencies. We realized a lot of projects till now. ICT technology almost last 10 years was popular in Turkey, but I tried to explain the all example what they did in different countryside, in different town and association cooperatives. But actually, we are living in the semi-dry climate conditions, almost climate change effects we are feeling in these conditions. We have limited water resource in, especially in central Anatolia, almost less than 300 millimeters per year annual precipitation. When I look at the old history, you can see a lot of channels, waterways in different parts of the country. Now this is historical place. You can see that one. Actually, in Turkish conditions, that period started in 1903, supported by the Ottoman Empire period. In that times, first regulator constructed in near Konya. In that area, almost.
Dr. YILDIRIM, just
yes.
Put it on the slide mode, because somebody has said that it is not on slide mode. So put on the slideshow mode.
From
This
the bottom?
one?
Here.
The button is that right?
No, you have closed that. On the bottom of your screen.
Yes.
There is one, no, on the task, on the PowerPoint itself. There is one button. Slideshow.
This one?
Come to the right.
Right at the bottom, the orange bar is there. You can see the orange bar.
I cannot see.
Hello.
That's why.
At the bottom of your presentation.
There's not that kind of button. Which color?
You can, in the PowerPoint window at the bottom, there is a zoom kind of you know, slider there in your extreme right hand corner.
Yeah, now it's perfect. Now it's perfect.
Yeah, now it is perfect.
Okay?
Yeah.
Okay, don't worry. I explain again. The first irrigation project, the Konya Irrigation Scheme project, and realized with European people in that time to extend to reach the water from Beyşehir lakes to central Anatolia lakes. Still, most of the area in that agriculture activities is very high. Farmers adopted all kind of new technology they was, but the main problem, energy costs and year by year, well levels is decreasing. After that, in 1945, the first project is started in two areas, Tokat, Kazova, and İzmir, Menemen. Still, these two schemes has old systems. To manage the water is really difficult. After 1950s, they started to construct open channels, concrete methods, and almost 2/3 of the country irrigation system has a channel systems. After 70s, we transferred this canalettes technology as a new technology in that times from the Italy, and to pass the all fit slope easily, they preferred. Nowadays, we don't have any factory supplying any retail material. After 1980s, we started to use low and medium pressure pipe irrigation systems, and still that kind of system is working. Only pipe type is changed nowadays. After 19s, we start to use high pressure pipe irrigation systems, still going on that kind of systems. All pipes produced in Turkey conditions. We have a lot of factories, pipe factories. Also, we export to this kind of both outside. After 2000s years, we start to use ICT technology. Generally, it started in dam conditions to control the water level. When they produce the electricity in that dam, that kind of mechanism adopted open the gate and to control the level of water, that kind of water. In Turkey, almost two dams that has that kind of ICT technology, and we are using local manufactured products. But we must ask this question: do we need that kind of ICT technology in irrigation areas? Yes, we must say, because to control the water is very difficult. Almost nowadays, irrigated area, 6.5 million hectares. That area managed in three different kind of organization. The main organization, State Hydraulic Works, they control the 4.21 million hectare of the countryside, around the 200 irrigation associations. GDRS as a rural affairs. Now that organization, it was closed, but they opened the systems and they transferred that system to most of the irrigation cooperatives. The number of the irrigation cooperatives of countryside more than 2,500. Almost a private irrigation system, it's more than 1 million hectare. Two parameters is very important that area. If all countryside average the irrigation efficiency less than 50%, also irrigation ratio approximately 60 or 65% of the countryside. When we look at the current status of the irrigation networks, only 28% of the system has a pressure pipe irrigation systems, and all of that one, sorry. That pressure pipe irrigation systems, we have the general different kind of ICT technology. Also, in some irrigation association has an open channel system. They are using ICT technology to open the gate and close that kind of technology. After I will explain one by one all application in Turkey. And almost more than 56% of the water supply from the dams. The main reason to transfer the surface irrigation to trickle or sprinkler irrigation system to save the water. Otherwise, lack of the water, we can supply the exact amount of the irrigation water requirements. Still, this summer, especially we are waiting some problems in Western Anatolia and Central Anatolia. In some associations from now, they said we can give 2 times irrigation water to each field. That's why the farmers looking for different crops which are consumed less water. Automation and decision support system in irrigation is started, implemented in new projects, especially new project of the DSI. It covers that kind of cost to control the water in some level. And that projects are used in the modernization of the irrigation schemes, and that have been turned into closed system, pressure pipe system, with the scope of the rehabilitation project. A plot project, pilot irrigation automation projects are carried out in the Western Anatolia, 21 regional director of DSI. They used different ICT technology in that area. The irrigation time and amount of water can be determined by user organization according to the plant pattern by remote control system installed on the hydrants. Irrigation can be started by the center or mobile phone application without going to the field. In open channel networks, hydraulic channel gates can be controlled by remotely. In this phase, the amount of water needed will be allocated to the water users according to plant pattern, and excessive irrigation will be prevented. Our first examples, it starts almost 2004, something like that. That area, all irrigated area, more than 10,000 hectares. In Western Anatolia, Söke is close to agency, and cotton the main crops. In that times, one electronic company entered this subject to invite the irrigation associations. What they did in the first projects, they prepared all layers in the geographic information system platforms. After that, they developed their softwares. In that times, the first purpose to collect the irrigation fees regularly, to determine the crop pattern, what's happening, because for different crops, they collected different amount of fees. And after, in the second step, they use another ICT technology to control some channel gate. And after that, in the third steps, they start to use mobile irrigation statement and remote cover management accessive application. At the end of that project, now they have one decision support systems. They can control the water level in the dam. Also, they can control the all channel level and the graphic. That company had a good experience from this project, and they did a lot of ICT applications, and they construct and build that kind of systems, that one. But they are looking from the operation side of the irrigation systems, and to save the water in the field conditions, till now didn't interest us deeply. Central Integrated Agriculture Irrigation Automation, the institution that manages agricultural irrigation. It is an electronic agriculture irrigation SCADA automation system in which software and hardware are operated in an integrated manner, managed with the scope of the irrigation plan, and according to existing instantaneous water resource and water budgets defined to relevant institution basin area of irrigation. In that area, some irrigation cooperative associations interested in to control the water in the hydrant level, some of them to control the dam level. It depends on the requirements. They use this kind of technologies. Another ICT application, Korkuteli Irrigation Association, is almost 50 kilometers far from the Antalya Centrum. They have a dam. The water resource is very limited, especially agricultural drought in some years happen. But they are lucky the main crops, fruits, especially peach, and for good quality and different variety. And they export also that kind of dam. Because of the limited water resource, the dam level, they started to use subsurface drip irrigation in field level by the farmers. But irrigation association by these systems, they control wireless systems, radio wave systems to control the hydrant valve, and every 2 weeks in same area getting the water, and also from the center of the irrigation association continuously they are observing, and also if we see any problems in the systems, directly they are going to that point of the field and they solve the problems. This system is still working well, but if irrigation association, the manager, also engineers can follow the all irrigation system. The main problem in that area, as I said before, the limited water resource. These systems have to them to control the water and save the water. Bayırköy irrigation scheme, that area in this project, or this is new project, the rehabilitation project of the DSI in the Western Anatolia, and they used a lot of kind of ICT technology. This system has a hydrant all field levels. The area not so large. Most of the farmers try to use drip irrigation. They can control the whole system from the remote. Also, they have some tablet, iPad or mobile application. In these systems, the most interesting point, prepaid water meter they are using. All farmers, before using the irrigation waters, they must pay the irrigation fee, that organizations, and when decide to use the irrigation water by a card, they can open the that water meter. When they finish the irrigation system, they can stop, or the credit when they finished, that system automatically stop it. The Amasya, almost 250 kilometers far from the Ankara. In that area, also in that dam, the water source is limited. In that area, what they did, they controlled the main valve by automations. By these systems, they use the irrigation water is very carefully, and they observe the all dam water level countryside. By means of this 2 million cubic meter water they saved last year. And also this system, Irrigation Network Special Information System, this system started to use by DSI, State Hydraulic Works organization, to control the 200 irrigation associations. They web-based digital platform that will be enable the monitoring, evaluation, and reporting of activities of facilities operated by the DSI, whose operation, maintenance, and management responsibility has been transferred. In DSI control the all irrigation associates by this program. The software basically aims to monitor irrigation facilities geographically and to meet the needs of water user organization through the single dam. Main structures of the DAT system, as you see, that system has a irrigation management, measurement of irrigated area, maintenance, audit, document and management, procurement, messaging, reporting, accounting, software background. Centralized data security controlled by DSI. Standardization of reports was developed. Effective use of external service, saving time and labor, easy control and inspections. That's why that SUTEM software connected land registry and cadastry information systems. When in this system change the owner of the parcel, automatically SUTEM transfer that data to own system. Central population managed systems to control the farmers, they are living or not, something like that. Also, this program connected by the Ministry of Agriculture farmer registration systems. Also, special real estate system connected by these systems. That company developed this system for DSI. After that company also developed new software. Still that company is selling to all different organizations. What they did, they started to this point measurement of irrigated area at the beginning point. Now they are using the European Space Agency product Sentinel tool. Automatically is free remote sensing data images. They transfer that images automatically, and they are preparing the regularly crop map to full records that kind of data. Electronic water management system in basin-wide west realized in the Western Anatolia, Büyük Menderes Basin, and they can control all water levels in the basin level or daily, even in secondly, hourly, they observe all weather data, water level or channel level, that kind of data. They have different sub part of the monitoring systems: water level, regulator level, hydrant, groundwater and groundwater measurement station, meteorological measurement, soil and plant observation station, drinking water monitoring system. They have control. That director of DSI in that region observe and collect this data automatically and regularly. This is the best example according to my opinion, my experience. Ali Beyhu Irrigation Cooperative is in Central Anatolia. It's almost 40 kilometers far from the Konya. In that time, water level in groundwater level more than 100 meters. At the beginning stage, they started to control wells, pumping units, is which one of is open or closed by SCADA systems, and to use the effectively data. After that, like credit card, they pay irrigation fees to store the credit discard. When they go to near the well, they read the blue part of the dead area. In that times, they connected the mostly in that area sprinkler irrigation systems, their own polyethylene pipe, and after that push the red button and automatically started to irrigation water in field conditions. Farmers has a two option. When the credit is finished, system automatically can stop. If they have more credit, only wants to use irrigation well 3 hours, 4 hours, in that sense they are going to near the well and push the red button, stop the irrigations and disconnect the air pipe. But the energy cost is very high in that area. By collecting that kind of systems, these cooperatives has they produce electricity by solar panel. By means way, first they decrease the irrigation fees. In the second step, their purpose to use some sensors to observe the soil water content, and after that, observing that data according to the soil water content, they will realize the irrigation, and they are thinking to determine the amount of irrigation application. As I say, in Turkey, a lot of companies working on ICT technology. This is the critical point. You can find different kind of equipments: prepaid irrigation valve, prepaid irrigation management system, online well tracking and prepaid irrigation management systems, and irrigation intelligence, site-specific weather data. That kind of system for irrigation cooperatives and irrigation associates is year by year increasing the number of the ICT equipments. We can see easily. In farm world, especially big farmers, from the farm irrigation, when they get the farm irrigation systems, they try to buy that kind of ICT technology to control the water. By cell phone, they open the irrigation system and they close the systems. We can see that kind of systems, especially in big farmers with good economic conditions. And year by year, that kind of system is now is increase of country size. Mobile application, another software application is very easy. Also in soil-less culture in greenhouse conditions, into company develop fertilizer and fertigation equipments easily. And in some areas, one company developed one cell phone application to control the water from their home and open the gate and close that kind. It is very cheap, almost less than $100 to one connection points in Turkey. The price is not so high, the competition is very high. And I try to explain what's happening in Turkey. Thank you very much for your listening to me.
Thank you, Dr. Yildirim. It was a very interesting presentation. We looked at the macro level of management for large irrigation projects as well, and the use of the ICT technologies in those kind of scenario, which will be useful for the countries which are having developed large irrigation systems. We also have with us Ms. Mary Jean Chai, who is the chair of WGIDM, and we would request her also to provide a brief remarks on the webinar, which is also pertaining to her area of work as well. So we'll invite Ms. Mary Jean Chai for a brief remarks.
Okay. Thank you very much, colleagues. Good morning, good afternoon, and good evening. I really appreciate the fact that ICID has come and made our webinar into fruition. Thank you very much also to Dr. Elmahdi for taking the initiative since our meeting in November. I appreciate it. It's the first webinar that our working group has had. And thank you, Dr. YILDIRIM, also for the very interesting presentation that you made on Turkey. My question, firstly, for Mr. Elmahdi is, I like the fact that you're looking at apps which are can be utilized, especially with smallholder farmers. My question is, in your development of your IRWI app in Egypt, was the app taken up quickly by the farmers, or was there resistance? Because that's what we're finding out right now. It's different with commercial farmers. The uptake is quite swift. Because they're willing, they want to make their profit margins much bigger. It's more difficult for us with smallholder farmers for the uptake of apps. And often we find it's not only the resistance, but the level of learning of our farmers is part of it. What was that your experience in Lebanon and in Egypt? And my next question, basically for Mr. YILDIRIM. Sir, your irrigation schemes are massive. In South Africa, we minuscule compared to what you're using, and yours is very high tech on the management side of the irrigation schemes. In terms of your farmers, especially the smaller farmers, are they? What measures are you putting in place to ensure that they are also involved in terms of managing water on their small farms? Thank you.
Yeah, so I think Dr. Amgad might...
the uptake. Can you hear me?
Can hear you.
Can you hear me?
Yeah,
Yes.
We can hear you.
Yep. Okay. So I will answer the question from Dr. Mary about the level of uptake by smallholder. So in Lebanon case, because we work with an existing application that already used to have 600 users already. So that was easy because we just upgrade, and from mouth to mouth word between farmers, the people who start to use that irrigation module went up from 600 to 650 in 2 weeks. If we look at in Egypt case, so in Egypt case, actually we've been surprised. When we started, we had that feeling that Mary mentioned, like where smallholder farmers are not really willing to take that information, or they might be not interested as well. But we actually providing the service for free. So just to make it very clear, the two applications providing that service for free, so they don't need to pay. So what we found actually, because we providing that information, they were looking for anything can really assist them. And it actually came during also the time we launched the app was actually during COVID-19. It was in around July, August. And at that time, they were actually lacking any access or zero access really to any extension service they even might used to have. And that brings that momentum for them to uptake that information that coming free for them. So when we started the launching of IRWI application in Egypt, we have trained 90 farmers. 80 of them had download the app. As an active user were only 60 to 65. However, over 3 months, we went from 62 active user Now we are above 300 users. So that actually show us they are actually we're looking to have such type of service and also have that information. And currently it's mainly depends on mouse to mouse between farmers. So farmers talking to each other. We are not doing any campaign so far at this stage. And we every day we see like a new user coming in. We also, because allow them through the application to, they send us a feedback. We have now a nice list of feedback. They actually asking for more crops. So once we finish the summer season, they become saying, where is the winter crops? I need the winter crops to be in, because they already start to rely on the application, and that show that value. So you start simple and then you start to bring in new information, and that will increase the level of uptake and use. Thank you.
May I speak? Yes.
Okay.
Yes.
Yes, you can speak, Dr. Yildirim.
Dear Mary, actually in small farmer generally doesn't use that kind of technology. In last 2 years, in cell phone application, open and close the irrigation wells, small farms start to use that kind of, because the cost of that equipment connected to well less than $100. And to control the soil water content and management of systems, small farmers doesn't interested in that stage. But who has a value-added crops and who has a irrigation systems, subsurface drip irrigation or mechanized irrigation system, center pivot and linear moves, they started to use that kind of cell phone application systems. And farm irrigation equipment suppliers started to supply that kind of ICT equipment for some farmers. They have some examples, but this is not so common. And when I can say one thing, in research level of research organization in universities and Ministry of Agriculture, we follow all meteorological data from our computer or our cell phone. This is completed that time. Also, we are observing soil water content in all research from by remote. According to that level, we are going to irrigate, and it gives that idea. For example, we are using one sensors, almost 120 centimeters, mainly Australian Centec organizations. Every 10 centimeters, we are following the soil water content. That kind of data, it supplies is very good data. It started that one. To save the water, subsurface irrigation system is very popular. We complete the countryside research facilities, and especially in Western Anatolia for vineyards, for grape, farmer adopted that one. And in this stage, by new farm, young farm, by ladies, that kind of mobile application transfer easily, that kind of background accept that technology easily. Thank you.
Thank you. Thank you very much, Prof. and Dr. Elmahdi. Thank you.
Well, thank you, Ms. Mary Jean, for a very interesting discussion and acknowledging the role of both our eminent speakers. What we notice is that we have the President Honoraire Felix also as a part of our audience, and I would request him on behalf of all of us to give his views also to the gathering. So if Dr. Felix is there, I would request him to please share his views.
So he can also activate his video also if he is available.
So he's not there, I think, because
I'm not
he's not in
finding
the
his
panel.
name in this list actually. Earlier I did find just little bit while.
Earlier I have put. Okay, sir. Please continue with others. We got a few more. Dr. Ghani is there. We can go for Ghani.
Actually, before that, what I'll suggest that there are a number of questions for Dr. Amgad and Dr.
Okay.
Yildirim. And then I think Dr. Amgad and Dr. Yildirim, they might be able to see the questions also in the question panel. So what we can do, we can take some of the questions, keeping in view the time constraint. So, and then reply can be a brief reply so that we can take more questions, we can reply more questions. So Dr. Amgad, if you are able to see, then you can start. Otherwise, what I will do, we'll read from here, and then you can reply. And once you see the question, you can just go to the question, speak the question, and so that other attendees can know that what is the question. So Dr. Amgad, you can start with the question.
Great. Thank you, Harsh. The question I see here is what factors are taken into account for the ICT system fee for the irrigation? And the second question, can farmers afford the fee or is it subsidized? So in terms of like the factor that being taken into the ICT system fee. So as we are working with public institutions in the two countries, and we aiming to reach the smallholder farmers from the beginning. So the decision was made actually to develop that solution and that technology and to be owned by public institutions, and the public institutions will provide that service for free for the farmers, because they see like they can actually, as a public institution responsible for the extension service, so they see they can cover the cost of development through reducing the extension service they are provide, or using the budget that provide for the extension service to actually maintain that ICT solution that actually come with really a minimum cost to maintain in comparison to if I give you an example of Egypt case, for example. So you have 27 governorates, or you have 9 million faddans, and to serve that farmers who are around like 2 million farmers, to serve that farmers, how many extension service do you need? Currently, we have seen no new recruitment, so there is a decline in that number of extension service officer. And if you start to digitize that service and move to ICT, you can actually continue to provide the extension service that the country aiming for with a minimum cost. And that's why that they were happy to carry that cost and provide that service for free to the farmer. So in both cases, the service is free, and a farmer can just access the information. They just need an internet on their mobile, and they can get access to all the information that the application can provide. I don't see other question, Harsh. If you see other, please.
What I'll do, I'll read the questions because they have not been flashed to you. Whether you can, if you open the question box, then you can see all the questions also as a panelist. But I'll read it, some of the questions for you. So one question is, what is the level of ICT adaptation among farmers in Egypt and Lebanon?
Yeah, if we talk about like the level of uptake between the two countries, so it's not like orange to orange comparison here, because in Lebanon, the application was already there and they have already a number of users. But in Egypt, like the application was totally new, and new user at all. But if you look at for the same time frame for like a 3 months since the application being launched, if you use that as one standard comparison, so in 3 months in Egypt, we've been able to have 200 almost 220 user, but in Lebanon it was only 50 user. Yeah, so you can use that as a comparison to show the level of uptake.
Yeah. Then next question, Dr. YILDIRIM, is for you. The question is, can we use the ICT for experimental station? What are the parameters that must be measured to install ICT in an experimental station?
And actually, in our research stations, we have a meteorological station, and they adjust the hourly data. First one, all meteorological parameters still going on all the year. That kind of, it is easy and very cheap way. And that kind of technology, mostly METOS technology in the agriculture meteorological station purpose. Also, before I said, we are using some synthetic sensors for observe the soil water content, and actually how to change the soil water in soil profile and crop that one. And also they connected this kind of ICT equipments very easily. Also, year by year, we are observing the water amounts, the water matter some in the research. This is the critical point. What is your purpose to measure and how? Question. This is the main questions. You can adopt these technologies is very easily to experimental stations. What I believe, all researchers must have that kind of data to explain the results easily. Otherwise, if you don't know the amount of water or any other data, that can year by year, my observations, or some sensors for crop measurements, for example, some infrared radiometer, because it shows the water stress of the crops. That kind of equipments we connected some external or internal part of that kind of systems.
Thank you, Dr. YILDIRIM. Dr. Amgad, there is a similar question for you also. Can we use the ICT for experimental station? What are the parameters that must be measured to install the ICT in an experimental station? Can we use the ICT for experimental station? What are the? It is the same question. So the similar question has been asked for you also. So if you can just, from your experience, you can just highlight briefly.
Yeah, I think Professor YILDIRIM has answered that in a nice way. If I can add, yes, you can do it, of course, in experiment station. For example, like they are, but again, come to the purpose of what you need really to monitor and assess. There are different type of technologies that can be actually used. So we have seen, for example, like wetting front detector, which again, it's a simple instrument. It's not really a fully ICT, but it can be used with smallholder farmers if they are like within an irrigation scheme. They use the same crop. They have similar soil type and irrigation type. You can use that instrument who costs really nothing. It's less than $100. And then you work from upstream. You install that system upstream, and then you can inform all the farmers downstream. There is other sensors that can also work on that, more advanced, like chameleon sensor, for example, that tell you when and how much to irrigate, and that can be linked to like your smartphone or iPhone, that actually can tell farmer specifically for their field, again, that information. So it's really come to the purpose of that and how you can design your experiment and how many sensor you need and what type of information you are after, and how you can link that local sensor with already the global dataset or the remote sensing dataset that's already available as well.
Okay, thank you, Dr. Amgad. Then another question which we can take for Dr. Yildirim is how many farmers percentage are using the prepaid cards in Turkey? What is the average cost of irrigation water USD per cubic meter or per 10 cubic meter?
Actually, nowadays in irrigation cooperatives, which based on which are used this kind of system, less than 10%. When I look at the Irrigation Association systems, which system as a new has a prepaid card. For old system, for surface irrigation system, doesn't have that kind of systems. But all cooperatives, when they transfer the surface irrigation system, the pressure pipe irrigation system, they are automatically using that one. As you know, all over the world, to collect the fees, not so easy, because management costs and another cost, also energy cost is very important. Also, Mr. Suresh Kwame asked, the price irrigation fees is changed extremely, depend on the energy cost for cubic meter, between $2 to $17 last year. If the energy cost is very high, in that times, it's very, very big problem. In that area, that cooperative has a prepaid cards. Otherwise, they cannot collect the fees. Thank you.
Another question to you is just, you can just briefly mention. Thank you for the presentation. I would like to get more information on how Sentinel data can be used for moisture monitoring in irrigation scheduling.
Actually, as you see, Sentinel data has a thermal bands. This is still in research level. To determine the crop type, to prepare the crop map, when you look at the internet, onesoilmap.com website supply some crop map data. In Turkish conditions, one company, Sutem, they produced for that one. They started to determine the crop map. But for the management of irrigation to Sentinel, almost every day you can get that data. The size of the field is very important. Resolution is very important in that times. By this way, we are working on that data for drought effects in the dry conditions, and you cannot use that kind of Sentinel or any remote sensing data directly. You must produce some indices or indexes and some formulation and method adaptation. But what I see, thermal bands, it gives data irrigation effects, but to observe daily and to develop the decision support system, we need time, I think, also in research level.
Yeah, some of the participants are asking for your email IDs so that they can interact with you in future. And what you can do, we'll share with them, all the participants who have participated, we can share the email ID. But if you can put your email ID in the chat box and then send it to all, so I think it will go there. And then some of the participants are asking for presentation. So if you agree, then we can share your presentation in PDF form and we can upload on our website so that if interested persons may download it. So if you agree, then we can, in PDF form, we can upload it.
I am agree. There is no problem. You can share it by ICID. I try to help you. Yeah.
Okay. I think Dr. Amgad is also agreeing for that. So we can.
Yeah.
What we can do, because time is already, we have running out of the time, because we have planned it for say 1.5 hours or so, but we had already crossed 1.5 hours. So we can take say 1 or 2 more questions, and then rest of the questions we can share with you, and then you can respond through to us, so that we can we can put the response on the website with along with that question. So one question for Dr. Amgad. Is there an ability to make yield forecast in your app? if you have such function, what is the difference between forecast and the fact?
What is the relation between forecast and
the fact, actual position?
Yeah,
Comparison
all right.
between forecast and fact.
Yeah, the current app is not really forecasting the yield, but what it tells the farmer is how the crop behave during that time of irrigation. So we tell based on the level of chlorophyll, we tell them how actually the level of greens on the field, and we translate that to a dry matter using a simple function with coefficient for each crop. So what we tell the farmer is your crop is healthy or not. So after each time you irrigate, and also that if you do a harvest today, what would be your dry matter or your yield. But we are not doing now the forecasting yield, like, yeah, but there's actually a function that actually came through our feedback as well as a required, and that required, of course, a crop forecasting model, which is, it wasn't really the focus of what we did so far.
Okay, thank you, Dr. Amgad. One more question we can take for Dr. Yildirim, Professor Yildirim, is that how we can calculate the ETO for the plant in ICID technology?
Actually, we are using the standard permanent methods in Turkey. We prepare the last 30 years data, used meteorological data. For 10 days, we supplied the one guidance, and in the 259 center. That's why by this way we have a meteorological stations. We use methods. In that time, hourly data we are getting that one, and daily base we observe the reference evapotranspirations per month FAO modification. There is no big difference that one. Also in our research we are using the that kind of data, reference evapotranspiration data, to determine the amount of irrigation water according to systems. We correct the efficiency. My observation also nowadays virtual meteorological station started to be popular. Some farmers getting that data from that company, year-based payment, yearly payment, they are doing that one. And also you can see some data, some climatologic models data in internet. You can transfer that data, that use, because after one day you can get data, some interpolations. In the research level, you must follow that station from your own stations. But if you are farmers, some new companies started to supply that kind of data to farmers' cell phone, especially frost emergency warning, that kind of warnings they are getting to directly. My suggestion to use the reference evapotranspiration data, the important is local crop coefficient data, and they can use the FAO data. They don't make more mistakes, I think.
Yeah, Dr. Amgad and Professor Yildirim, last question to both of you, because that is of interest to number of participants from other countries. So whether these technologies can be used by other countries, that is one question. And second is that smartphones are needed for use of ICT and these applications. And are our farmers then literate enough to use such applications, or such lack of literacy would be a limiting factor? So briefly, just quickly, you can answer these two questions, both Dr. Amgad and Professor Yildirim. And then after that, we'll have I'll hand over to Mr. Pandya for his closing remarks or further action.
Thank you for that question. So definitely, yes, the applications that I have shown can be actually applied in different countries. And we are actually just agreed now to apply the same concept like IRWI application in a number of countries. So we are going to do it in Jordan now, and also in Palestine and in Sudan. And Tunisia, it's in a discussion at the moment. So we will going to apply the same concept, the same approach to those countries, but we'll customize it, of course, in the way they want to see the information, because language is different, even if it's Arabic, but the dialogue is different as well. So we'll apply the same technology in those other 3 countries. Yeah.
Professor Yildirim, you will also like to comment on that?
ICT technologies equipments can use all countries. That's not so difficult. The important things, the manual and that kind of communication, language or other things. Most of that software or electronic person try to use some symbols instead of the written, and they can transfer that kind of technology easily. But only one weak point, my opinion, there is no standardizations. In these conditions, as an irrigation person, we must explain exactly when you explain the software engineer or electric engineer, they must understand us exactly. There is a misunderstanding, miscommunication, I can say that. Also in literature, when I look at the some papers at that, irrigation automation papers, mostly in India, and that literature, they need the standardizations, but software engineers, what I saw in Turkey conditions, to change the figure and other things, show activities differently to sell their market, but mainly at the base, everything is same, technology same, and year by ICT technology developing well. Thank you.
Okay, thank you, Dr. Amgad and Dr. Yildirim. Now, Pandyaji, you can take it forward. And I'm seeing that Professor Ghani and Irina, they are there, our Vice President Honorary. So if you wish, you can, because time is already running out. So if you wish, you can ask them. Otherwise, you can give your closing remarks.
I think we have, of course, gone quite a lot above our time, and probably our slot may not be really, available for very long. So I think we can invite Dr. Ghani and then Dr. Irina for giving their remarks for, let's say, about 3 minutes or so, and then we can try to conclude. So if Dr. Ghani can be given the rights, then
yeah. Dr. Ghani, you have self-muted, please. You can unmute yourself and start speaking. Dr. Ghani, please unmute yourself.
We can request, or we can request Dr. Irina in the meanwhile, if he is available.
Dr. Gundugudu, Hussain, Dr. Hussain, can you speak, please? Please unmute yourself and start speaking.
Hear me?
Yeah,
Please,
Do you hear me?
We can hear you. Yeah, we can hear you.
Okay, thank you very much. Okay, thank you very much, Mr. Secretary General and the board presenter. I really enjoyed by hearing those on ICIT. But from my experience, what I learned actually, this kind of technology is a based on the digitizing or high tech issues should be applied. But the scale is important. On the scheme level is okay, no problem, because there's one body, the supplier, water supplier, and controlling everything. Then you can adapt all kind of ICIT technologies. But in one way, somehow we have to have a good link between scheme level and farm level, especially end user, farmers. Farmers are generally prefer on communication in a very friendly approach. And they want to see it, and they want to touch it, and they want to, disseminate information, right? Just by using their 5 sense of humor, right? So, I mean, on farm level, somehow we should create a good link to disseminate the information and the communication. As far as I understand, the Egyptian side and the Jordan side, unlike the pandemic situation is somehow is a little bit obstacles. This is what I believe, that the farmers should have a friendly high tech. Okay, this is my experience actually. But on the scheme level, okay, most of the country, they are okay, they can use that type of systems. But when you come to through the farm level, it's a little bit problematic. Thank you very much again. This is my comment.
We have Dr. Baba also. We can, because Mr. Ghani and Dr. Irina is not there, so we can just request Dr. Baba to give him brief remarks.
Dr. Baba, unmute yourself.
Yeah. Dr. Baba.
Dr. Baba, please unmute yourself.
I think he's not.
I think he is also not there.
We can close it.
Maybe we'll try to close this, and we will again take up this very vital issue at a later date as well, because this is an issue which is covering the entire sector of irrigation, starting from the project planning and going all the way up to the project implementation and the last mile, that is the last stakeholder, that is the farm. Well, ICT technologies have a great potential, as has been demonstrated by both the learned speakers, and simultaneously they have also brought out a very important aspect, that is the selling or the marketing of these technologies for an easy adoption by the end users. The real success lies in the ability of the end user to be comfortable with the solution that is being provided, and for that a huge amount of work towards the familiarization of the person, as well as understanding the needs of the person and categorizing those needs, so that ultimately the app is capable of providing all those needs in a nutshell, in a customizable form, is something that is most important for making a success of the ICT technologies in managing the agriculture water. At the end, I thank both the learned speakers, that is Dr. Amgad and Professor YILDIRIM, for having made a very nice presentation and also provided very learned and very informative answers to various questions. And I do hope that our attendees will be able to take the benefit of these, and maybe having more questions, we will be able to answer this in our forthcoming congress. Also, we'll be addressing some of these questions. So I would invite for them to really take part in those proceedings, and then benefit more from this area. It's a very dynamic and a very developing area, and we should actually try to do more on this which will help in promoting the efficient agriculture water management and ultimately handle our climate change adaptations as well as our growing populations. So thank you very much. Thank you for the speakers, and thank you all the attendees for having very patiently listened to the presentations and made very intelligent questions from your side. Thank you very much.
Thank you.
Thank you, everyone.
Thank you very much. Thank you, everybody, and
Thank you.
thanks for participation.
Thank you.
Thank you. Thanks for your participation.
Thank you, everybody.
Thanks.
हम लोग रुक सकते हैं थोड़ा सा.
ठीक है. नहीं सर, बहुत लोग पीछे हैं, उनको भी सुनाई देता है.
नहीं, हम उसको बाद ही करेंगे.
ठीक है.
या हम बाद में बात करेंगे.
कल बात करेंगे. We'll talk tomorrow.
Yes, I'm closing this.
Yeah.